And we're live, so please welcome Isabel.
Sorry about that delay. We were having some technical difficulties, but hi, everyone. Thank you for having me. This is my first time at UIKonf, and it's awesome so far. And this is actually my first time doing a technical talk ever. So I'm really excited about it, and I absolutely welcome any feedback whatsoever. Afterwards, you guys can talk to me. I know people are really passionate and excited about architecture, and so am I. And so, I encourage us to talk about it later. So 4 steps to architectural epiphany. So let's give you a quick intro on who I am and why I'm here talking to you about architecture. So that's me. And I've been working as an iOS developer for 3 years professionally, and I spent all of those 3 years at a company called Rent the Runway, and this is a fashion startup based out of New York City. And just a quick intro on what Rent the Runway does, we rent designer dresses and fashion accessories and handbags and jackets and everything you can imagine for a fraction of the retail price. So if you're going to a wedding or something like that and you don't want to buy a dress, you can rent it for 4 days and return it instead. And so when I joined 3 years ago, the iOS team was 1 person, and they were 2 months away from launching their first version of the app. So this was a great time for me to join because I was really eager to learn about iOS, and I had just come out of school, and I had a really great mentor who was this iOS engineer, and everything was brand new. All of the code had just been built. And you guys know that feeling of when something is new and clean and it feels like nothing can go wrong and everything is clear skies. And it was that way for a little while, and I was really enjoying getting to learn all of these new techniques on how to make really cool interfaces and make really cool interactions and animations, and I was having a really great time kind of expanding my skill set coming in right from school. And fast forward 3 years later, so this was only a few months ago, and the iOS team had grown from me and another guy to 5 people. And we had added a lot of new features. We had refactored a little bit. We had gone through 2 redesigns. And one day, the product team came to us and they said, hey, we want you guys to implement this big feature. And this big feature was called Unlimited, and it was a completely different way to think about rentals. So it was this idea of being able to subscribe to fashion where you could pay a subscription fee and you could get as many items as you wanted within a month. You could recycle items. And so this concept, this business model, was fundamentally different from anything that we had ever done at Rent the Runway, because we were used to just renting and returning. And so when they came to us and they said, we want to build this into the app, this was such a huge feature that we actually considered building an entirely separate app for it. So this is just to give you some context on the size of this project. And then in the end, we decided not to build this separate app because we wanted to try it out, so we built it into the existing app. But it was at this point when I was looking at implementing this particular component of that big feature, and this was the combined shopping cart was what it was, and I'll show you something about that later, that I started to look around and look at what the best way to build this into our existing app was. And I started to feel a little weird, a little funny. And I'm sure all of you can relate that feeling that you get in the pit of your stomach that something's not quite right, that there's too much code in some of your files. And I was looking at this with a new perspective. I was realizing that over the years that we had been building new features and adding on top of our code, we hadn't really thought about architecture the entire time. And that's when I really became interested in architecture, and I started thinking about what are other people doing out there. And keep in mind that we had been using Model View Controller from the very beginning, and I didn't know that there was anything other than Model View Controller as starting out as a developer. And so I became really interested in architecture, and I started doing a ton of research, and I started playing around with some of these concepts. And this presentation is an accumulation of all of the things that I learned and some of the opinions that I have about everything and just my experiences as I was applying these concepts. So what are the goals for this talk? Number one is we're going to go through some common architecture patterns, and we're going to very briefly kind of talk about how they work and how they connect. Then we're going to try to take those patterns and identify some underlying principles of those architecture patterns. And then we're going to take these principles and we're going to apply them strategically based on the unique needs of your application and the future needs of your application, because everyone's work is different and everyone has different needs. And I just want to iterate that the point of this talk isn't to teach you how to implement these architectures or to act as an advocate for any specific patterns. And there have been some great talks, like the one we just saw, about some techniques that you can use to implement some of these architectures, like dependency injection, like MVVM, protocol-oriented programming and such, but I'm not going to talk to you about those implementations. Instead, I'm going to talk to you about how we can understand the commonalities of these common architecture patterns and the underlying principles on which they were built in a way that will allow you to be better prepared to make good architectural decisions by yourself and with your team in the future. Okay, so let's start with, kind of an obvious question. What even is architecture? And this is my definition. This is how I think of it, and yours might be a little different. Happy to talk about that. But I think that architecture is the intentional design of the interaction between the components of your application. So it defines the information flow between these components. It gives structure and purpose to all of your modules and your classes. And let's not forget the most important part is that architecture is intended to simplify your software. It should make it easier to read, easier to test, and easier to debug. Okay, so we're going to talk about some common patterns or architectural patterns, and there's lots out there, and this is just a collection of some that I found the most interesting. So MVC, the most obvious one, MVVM, VIP, and Viper. And Steve Scott did a really great job yesterday of talking in depth about MVVM, C in his case, and he introduced MVVM, and you guys are all iOS developers for the most part, so I know that you understand what MVVM is. So I'm not going to spend as much time on those, and we're going to spend more time on VIP and Viper. So MVC, it's absolutely worth mentioning and reiterating. Every iOS developer knows MVC because Apple talks to us about it all the time. So I think to summarize MVC, you can summarize it basically in two ways, and the two ways that it is flawed. And okay, maybe that was harsh. It's not flawed. It's used, I think, incorrectly. But so model view controller, the first problem is that the view and the controller are extremely tightly coupled. So much so that you can basically consider the view and the controller to be one and the same. And so actually from now on, when you see the block with the view on it, you can consider that to be the view controller. And number two is that it's taken very literally. And what that means is that we tend to come up with something, come up with a component or a functionality that we need to build. And we think it either needs to be a view, it needs to be a controller, or it needs to be a model. And that's kind of the very early thinking that I thought, and I think some early iOS developers have the same thoughts. And so, you're building something, and you think, okay, well, this isn't a model, and this isn't a subview or a view, so then this definitely has to go in the controller. So what you end up getting is a ton of random functionality just stuffed in the controller because we honestly can't think of a better place to put it. And so this ends up manifesting itself as the commonly said massive view controller. So one step towards separating some of this functionality that doesn't really belong in the controller is this pattern of MVVM. So here in this diagram, the view is the view controller, like I said before, and we introduce another layer of functionality called the view model. And this encapsulates really the presentation logic that needs to happen from your model that encapsulates all of the data that you're presenting, and any little tweaks that you need to do to get that to present properly in your view. So this might be something like string concatenation, or any sorts of presentation logic that you require for your view. And the way that the view model and the view communicate with each other is an implementation detail that some other presenters have talked about. You can use protocol-based programming, you can use reactive COCO, or you could use bindings through KVO or something like that, and that's something that is up to you. But this goes part of the way towards this idea of creating a separation of concerns, where the data and the data manipulation happen separately from the view and the view setup and positioning and all of that. So it's a little bit more modular and more decoupled than MVC, and it has pretty good readability and testability, and it's actually pretty easy to implement even on existing projects where you just want to lean out your view controller a little bit and take away some of that presentation logic that is in your view controller. So at some point in my research and in my experimentation, I came upon this concept of clean architecture. And this came from a blog post written in 2014 by Uncle Bob. And it had a lot of really interesting concepts that I'd seen before, but I'd never seen together kind of in one place. And the first was this idea of use case-based design. So use case-based design is the concept that you define a use case for a particular module that you're working on that is totally independent from the UI implementation of that. So that you could completely change your interface, you could move it to iPad, you could design something completely different from a UI perspective. But as long as the underlying business logic stays the same, you don't have to change any of the use case or the business logic layer or the code. So that's a really powerful concept. And I want to give you guys a little kind of, I don't even know what this is. This is an example that you can kind of think about when you're thinking about a use case. So this is a screenshot of a shopping bag. So very common in e-commerce. You have some items in there. Well, here you have one item. You have a shipping address that's already pre-populated in this case. You have some your totals. In this case, everything is 0 because this is an unlimited subscription. And at the bottom, you have a button where you would actually be able to confirm your shipment. And it's grayed out here because this isn't valid. Technically, the validation has failed. So if I showed you this, and I asked you, what is the use case for this view? You might be tempted to say, the use case for this view is a user should be able to view the items in their bag, to select a shipping address, and then to check out with the things in your bag. But when you really think about it, what I've just said is I've described 3 different use cases. And because a designer could come to me tomorrow and tell me, actually, this button on the bottom, we're going to make this a next button, and we're going to move to a completely separate view controller, and we're going to make a big button that says place shipment, and that's it, and that's all it's going to do. And so now we've removed this button on the bottom, but the bag is still going to remain. So the use case here really is a user should be able to view their bag. And that's one use case. Users should be able to change their shipping address is another use case. And users should be able to check out with their order, and that's a 3rd use case. And when you think about it that way, this is really interesting because we could display the bag and just the bag from anywhere in the app if we build it this way and completely redesign the app and put it on an iPad or whatnot. And we would be able to reuse this use case. He also talked a lot about the single responsibility principle. And what this says is that a software module should only ever have one reason to change. So it should only ever have one function. And every layer of your architecture should only have one specific purpose. And this makes it really awesome for readability, I think, because it makes it a lot easier to figure out what something is doing when that thing only does one thing. And of course, I think it also makes it a lot easier to test when your classes only have one specific function. This is a diagram that was taken out of that blog post. So it describes all of these layers as circles. And the outer layer here is your UI, or your interfaces. The green layer here represents all of the presenters, the controllers. And this is the presentation logic that is specific to the user interface. Then the red layer are the use cases or the business logic, like we just described. And then the inner layer are the entities, and the entities are just business objects or that encapsulate the data. He also introduced, I don't know if he introduced it, but he talked about this concept of the dependency rule, which states that source code dependencies can only point inwards. If we go back to this diagram, we see these little arrows on the left-hand side here that are pointing inwards. And so the dependency rule really is saying that any of the business logic, the inner circles, the closer that you get into the middle, shouldn't know anything about the outer circles, because this actually allows you to strip away the outer circles and reuse the inner circles as you need to. So one architectural implementation of clean architecture is VIP. And VIP stands for view, interactor, and presenter. So the interactor in this case represents those use cases that we talked about. So this represents the business logic of a particular feature, a particular module. And we also see here the presenter, which represents all of the presentation logic that is unique to a particular view. And then on the right-hand side here, we see the model or the entities. And so the view will ask for data from the interactor, which contains the pointers to the models, and it updates data, and then passes the response passively. It doesn't care who is listening, and this could be through protocol-oriented programming or whatnot, and that's why those arrows are dotted instead of regular lines. It passes this information to the presenter, and then the presenter is responsible for updating the view with the correct data. And so VIP is introducing another layer of separation further than MVVM, where the business logic is now separate from the presentation logic, and the business logic is really representing a use case for a particular feature. And even one step further from VIP, and this is an extension, again, of clean architecture, is Viper. It was referenced in the last talk. And so Viper stands for view, interactor, presenter, entity or entities, and router. And there's been names that have changed. I've heard the router also called the wireframe. It's very similar to the coordinator that Steve Scott talked about yesterday also. So the view in this case will ask for, or will pass the actions onto the presenter. The presenter interacts with the interactor that contains all of the business logic, and the interactor contains the pointers to all of the entities, and it will update the entities as it needs to and pass the new information to the presenter, which then decides if it needs to update the view, or does the router need to take over and transition from one view controller to another view controller. And so the router here, I have written under it, it's the navigation controller, but it's really more than that. The router acts as the owner of the view controllers and the view controller transitions. And it's responsible for initializing all of view controllers and the dependencies and presenting them appropriately. And any custom animations that you might do from separate view controllers might go in your router. So here's another way to look at Viper that is very similar to the clean architecture diagram we saw before, where the view controller is on the outside, the inside is the presenter, the interactor, and the entity. And again, you look at this arrow and you see that the dependencies are going inwards. So nothing on the outside should, nothing on the inside should ever depend or have pointers or references to anything on the outside. It should be able to do its own thing without having to reference anything on the outside. And this is, again, really powerful because you can strip away the user interface, create something completely new, and as long as the use case and the business logic remains the same, you could create something completely different around it. So Viper is the most decoupled of these architectures that we've seen so far. It's also very highly testable because it's so decoupled. But it can sometimes be difficult to follow, and readability might suffer a little bit. And for a new developer, it might be a little bit overwhelming to see all of these layers and try to connect how they communicate between each other. So, so we kind of did a brief overview of MVVC, MVVM, VIP, and Viper, and I apologize if I lost some of you in the process of going through these architectures. But they all have various degrees of decoupling, various degrees of complexity and ease of use. So you're still probably wondering, okay, so you haven't told me What is the right architecture to use? Does it make sense to jump directly into something that's very highly decoupled, like Viper? Or should you start from the beginning and kind of work your way up as your need arises? And I had these same thoughts myself. And so I started experimenting a lot with trying to implement some of these patterns. And I actually found that the more I thought about it and the more I experimented with some of these, nothing ever really quite fit the way that I needed it to. And I was getting really frustrated with this because I thought, am I doing something wrong? Is it too early to be using Viper? And so instead I decided to step back a little bit and to try and identify what are the common principles that all of these patterns have in common. And can I instead use those principles to come up with something that will work for me instead of trying to fit my needs into one of these patterns? So I realized, thankfully, that there are some underlying principles that all of these architectures are built on. And the first one, and the most obvious one that everyone, I think, knows, is the separation of concerns. Don't stick two things together that do different things. It's pretty straightforward. And it's related to the single responsibility principle, which is that when possible, one module or one component should only be responsible for one thing, and it should only ever have one reason to change. The dependency rule and the rule of information flow, that business logic or components that are more, I guess, like deeper into the circle, so models or business logic, should be reusable and should not be dependent on anything that is outside any of the views or the UI layers. And lastly, abstraction and composition. So as you move inwards, same with the dependency rule, you should try to make the components of the business logic and the entities as abstracted as possible, and because that actually makes them a lot more reusable. And composition refers to the ability to extend an abstraction to have more functionality when you need it to. Cool, so that was really relieving for me because I thought, okay, this is great. I understand these principles and I believe them, and I can apply them to my own code base and build a really awesome architecture that I'm really proud of. But is it time now to actually implement these architectures? And actually, no. So there's a few more things that you need to think about before you jump into the implementation. And number one, understand your needs. So the first one, what are you building? And this might seem extremely obvious. A product manager comes to your desk and says, build this, or we're going to build this. And if you jump right into, okay, I'm going to implement this without understanding what are you actually building, sometimes it's not uncommon to actually end up building something that's either totally wrong or only partially wrong, hopefully, because you didn't really understand what you were building. What are the use cases or use cases, and are these properly fleshed out, even with the product team? Sometimes the product team doesn't think of all of the use cases and doesn't understand how different components fit together. How does the feature that you're building fit with the rest of the application? Are you extending something that's really small and that's already been built and it's going to be a one-time thing? Or are you building something that is much larger and might be used in multiple parts in your application? Are you building on an existing app? Are you adding features to an existing app? How much refactoring might you have to do? Are you working with a lot of legacy code? These are important questions. And lastly, who's going to be working on this project? And how big is your team? And how are you going to communicate these design decisions to your team effectively? Number two, predict the future. So imagine that you are a builder. You build houses. And your client comes to you and says, I want you to build me a one-bedroom home. And you're like, yeah, awesome. I'll build you a one-bedroom home. I love building stuff. And you get started, and you build the foundation for a one-bedroom home, and you're really proud of it. And you're almost finished with this one-bedroom house when your client comes to you and says, hey, actually, my parents are moving in with me, and I'm having a baby. So I actually need this one-bedroom home to be a three-bedroom home. Oh, and can you have it done in a month? So all of a sudden, you look at your client, and you think, well, I thought you were going to only build a one-bedroom home, so I built the foundations for a one-bedroom home. And sorry, we're going to actually have to tear down everything we've already built and build it again with the foundations for a 3-bedroom house. So obviously, your client's not going to be too happy about that. And that's what predicting the future really is about. It's about when you're building something, think about how might this need to change in the future? Is this going to need to change a lot? Is there the potential for it to have to be extended a lot? So how extendable does your module need to be? How is it going to scale as you start to add different little complexities to this one particular feature? And how might your architecture or your design break down in the future? Because as much as we like to think that when we build something, it's built in the perfect way, it very rarely is. And so I think it's important to learn to recognize the telltale signs of that something is going wrong. And your intuition is obviously a good sign, but generally, if you're violating any of the underlying principles that we talked about earlier, then it's a sign you're probably going in the wrong direction and you need to rethink about what you're doing. So the point really is that you should be building your architecture with the future in mind, because good architecture should always be designed in a way that's going to allow it to grow and to extend to the needs of your application and of your business. And then I encourage you to think about how your architecture decisions actually impact the higher level business needs of your company, such as the ability to quickly iterate and add new features without compromising the existing functionality of your app and of your product. So finally, we know what we're building, and we know what we might be building in the future. So we're feeling pretty confident that we know what we need to do. So now is the time to actually implement the principles that we talked about. And so identify the minimum viable function. And what this really means is splitting up your feature or your module into components that make sense for the complexity of it. So define clear roles for all of your layers. How much business logic are you doing on the front end being the app, versus on the back end? And can you abstract, can you move some of that business logic to the back end? How are your layers going to communicate data? Are you going to use protocols? Are you going to use binding? And this is the time when you can really use some of those fancy tools that other people here at UIKonf, really smart people, are working on, like dependency injection and so forth. And really just apply the principles. And what does that mean? So that doesn't mean to pick an architecture and to stick to it. It means to really think strategically about what the function and the role of every single one of your components is, and how they connect to other components in your feature in a way that makes sense. And essentially, I guess if you're doing it right, the test should come much more easily. And ask yourself, where do you fit in this graph? So this graph shows that as the degree of complexity goes up, the degree of decoupling should also go up. And so MVC is right on the bottom here, because usually it works for when your project is really not very complex, and so the degree of decoupling is also very low. And as your project gets more and more complex, the importance of decoupling becomes greater, and that's why Vipers is up there. And I like to think about architecture like a startup. So when you are a startup, you're 2 to 3 people, 2 to 3 founders, and you're pre-funding, and you're poor, and you're all doing everything. And none of it is probably very good. But that's OK, because you're just building an MVP, and you just want to get your product out, and you want to test it. But now that you've validated your product, and you get some funding, and you decide to invest in your team. And when you invest in your team, you start to create specific roles, specific teams. So you start to have an engineering team, you have a marketing team, a sales team, and the teams become more specific and are able to perform better in their respective fields as a result. And of course, this doesn't mean that they don't communicate with each other, because that's obviously also very important. And it's the same with building your application. So you've implemented an architecture that you're proud of, and you followed the underlying principles, and you're pretty confident that it's going to scale well to the needs of your company in the future. So now the most important part in my opinion is to establish your standards. So communicate with your team. Once you've established something, a design pattern that makes sense, make sure that you get everybody on the same page. Because every single person on your team needs to buy into the idea that investing in good architectural decisions is good for everyone, for your whole team. And build good design principles into your team culture. And this, I'm saying this and I'm thinking, it's okay, it's easier to say than to actually do this. And I agree that that's true, that not everybody can always be on the same page, but you can work towards making this part of your team culture. And one way to do this, I think, is to define a suggested development pattern. So let's say that you start with an architectural code review, and then you suggest that developers start with the inner layer, so the entities or the models, and then the use case, and then work their way out into the UI. Number 3, practice architectural code reviews. And these are obviously very different from regular code reviews. When you're looking at a diff on GitHub and you're looking line by line, you're looking for syntax errors, et cetera, it's really hard to see the big picture of how something has been designed. So yeah, it might be annoying to have to do, sit side by side with someone to walk someone through what you were thinking, but I think that this is really important. Establish a strict organizational structure. So this really is just referring to your file structure and the way that you name your files and where you put them. So it makes it obviously a lot easier to find stuff when your files are neatly organized. And be consistent and be diligent. You have to really commit to your decision. Because if members of your team start to deviate and do their own thing, your architecture starts to fall apart extremely quickly. And I know we've probably all seen this happen. And lastly, document your work. Makes it easier for new developers obviously coming in when they can follow what your thinking was. And even for yourself when you come back to something after a long time and you can't remember what you were thinking. So what are some kind of overall conclusions that I found? The first one is that architecture is a process. And what this means is that it really doesn't happen overnight. You need to commit to it and to be diligent about maintaining high standards and about creating a culture of good design decisions within your team. And I mean, it really is, it's a team effort because everybody needs to commit to this, to believe that following good design principles is going to make for better code, for a better product, and that it fundamentally makes a difference for your business and the higher level business needs of your company and for your users. So make good design principles a part of your life. Really try to build it into your team's workflow as much as you can. And finally, just think outside the box and look at the bigger picture. So I think it's really easy to get caught up in the implementation details of a particular architecture. And I'm definitely guilty of that myself. But I think what we need to understand is that there's no silver bullet. There's no one-size-fits-all when it comes to architecture. And even MVC, where all these architectures, they're really just meant to be guidelines. And if you stop trying to force components into a particular box and you think more holistically about what the component should do now, what it should do in the future, then you're going to overcome a lot of frustrations. At least I overcame a lot of frustrations that way. And embrace the reality that there's never going to be a right answer. But there are good answers. And if you have the right preparation and a good mindset, then we can all be good engineers, but we can also be good architects. Thank you. Please, if you have any questions, please talk to me, any feedback. We'll talk after. So thank you.